Okay, this is the first video in the data section. This is really just by way of an introduction to the sort of things that we will be covering in this section, and which is all about how we gather, how we assess and interpret data. Very important concept is the idea of populations and samples. Typically, population is something interesting that we want to understand, and we describe that population in terms of parameters. Most typical parameter that we're interested in is the mean. So it could be the mean of the heights of all people in a country, something like that. And a sample is a subset of that data that we survey in order to use that information to estimate those parameters for the whole population. Okay, so we go on to talk about sampling methods. Ideally, what we kind of want to do always is to take a very large random sample in order to give us good estimates. Large random samples are expensive, so there are ways that we deal with that in order to balance the sort of the confidence that we have in an estimate against the cost of gathering the data. We're interested in histograms and percentiles. It's a kind of a bit of a rehash of stuff that you will have done previously. Histograms and percentiles, median and interquartile range, a couple of things. Median is a measure of central tendency. Interquartile range is a measure of spread or dispersion. So that's what we're interested in there. And you will remember perhaps doing cumulative frequency charts and using that in order to find or estimate medians and interquartile ranges. So those are useful sometimes. In other circumstances, we're actually interested in the mean and variance of samples. So if we're given a set of data, lots of numbers, basically, we have ways of calculating the mean is obviously sort of fairly intuitive, but calculating the variance, which is a measure of spread, we go into how that's done. And then we are also looking at bivariate data. So this is where we're taking pairs of data, which typically we kind of believe there may be some relationship between those two things, people's weight and their height, people's I don't know, age and IQ. Maybe things like that. Do we believe there's a relationship between those? So that's what we mean by bivariate data. Bi mean two, variate means these things vary. Covariance is a concept. It's a bit like variance, but it's where we've got this that's applied to bivariate data, so it gives us an idea of the variation of the pairs of data. Regression basically means if we got our bivariate data and we put it onto a scatter graph, again, something you will have done before, you will have drawn a line of best fit, quite probably, to actually sort of kind of project what the relationship is, the underlying relationship is between these two variables. And it's regression because we're basically going back from the data into the relationship. So that line we may refer to as being our regression line. And we're also interested in correlation. Is there a relationship, a correlationship between these two variables? So as one increases, does the other increase, or is it just random? So those are the things that we're going to be looking at in this section. All this kind of leads on to stuff about probability functions, which is in the next section. Okay, so hopefully that's given you a bit of an idea as to what we're going to be covering in this section, and I will see you in the next video.